Hello everyone. In this video, we are solving a problem from INMO 2020. Uh, if I guess correctly, this is the first problem. So this is a geometry problem. It says that let gamma 1 and gamma 2 be two circles of unequal radius with centers O1 and O2 respectively intersecting at two distinct points A and B. Okay, so this is A and this is B, intersects at A and B. The tangent to omega 1 at B. So basically this is the tangent to omega 1 at B intersects omega 2 again at C. So this is point C, and the tangent to omega 2 at B, which is this line, intersects omega 1 again at D. So this is D, different from B. The bisectors of DAB and CAB. So this is a bisector and this is also a bisector. Bisector basically means that we can conclude that this angle here is equal to this angle here. So these two green angles are equal, and also this is a bisector, so this angle here is equal to this angle here. Okay, meet again at xy. So I have already drawn x and drawn y. Okay, then it says that let PQ be the circumcenters of triangle ACD and XAY. So ACD is this triangle, so we need to find its circumcircle, and also XAY, so this big triangle. Okay, and we have to prove that their circumcircles, if circumcenters, if we join them, so suppose one of them is here, one of them is here, so this whole line is perpendicular to O1 O2. This is what we need to prove. Okay, so I have not yet drawn the circumcenters because I wanted to share some concepts before it. So let's try to draw the circumcenter of XD, circumcenter of DAC. Okay, and that is, we know that is P. So notice that circumcenter is the intersection points of the perpendicular bisectors of the sides of the triangle. So thus the point P is the intersection of perpendicular bisectors of AD and AC. Okay, and we already know that in a circle the perpendicular bisector of any chord passes through its center. So if we draw this line, this is the perpendicular bisector of AD. Okay, and similarly we draw a perpendicular bisector of AC, and the point at which they intersect, this is the point. And in a similar manner, what we do is we connect the, in triangle XAY, we also need to find the perpendicular bisector of XAY, and in a similar manner the perpendicular bisector of XAY, the circumcenter of XAY passes through the perpendicular bisectors of XA and AY, and they pass through the center. So if we draw something like this and something like this, this is the intersection of perpendicular bisector, and this is the point Q. So we basically want to prove that PQ is the perpendicular bisector of O1 O2. So how can we exactly prove PQ is the perpendicular bisector of O1 O2? Now to prove that a line segment is perpendicular bisector of, say, let me draw it here to convince my point. So suppose these are 2 points A, B, and we know that any point on its perpendicular bisector is equidistant from both A and B. So this is perpendicular and these two are equal. Then if you take a random point here, say P, and another random point here, say Q, then AP equal to BP. Why is that? We can easily show that these two triangles are congruent. Okay, this already follows from side angle side criterion, and so this side becomes equal to this side. So P is equidistant, and similarly Q is also equidistant. This distance is also equal to this distance. So in a way, you can conclude, if we prove that PO1 equal to PO2 and this segment is equal to this segment, then we already can say that PQ is the perpendicular bisector. Okay, this can also be easily proven, that suppose this is equal to this, and so this is equal to this, then the line joining them is the perpendicular bisector. Okay, so let's try to do this. We will try to prove that this is equal to this and this is equal to this. Okay, so first let's observe some things about our triangle. One thing to notice is that we will because say we first we will take another color. Yeah, because BC is a tangent, it was given that BC is a tangent to the first circle, omega 1 tangent to this circle. Thus, if we consider this angle here, right here, this angle would be equal to this angle. Okay, so let's make that concrete. Suppose we make this a blue angle. So this blue angle is equal to this blue angle. Okay, and in a similar manner, you can prove that this angle here, this pitch angle, is equal to this pitch angle. And notice that the suppose we hide this angle, green and red angle for a while. Oops, I erased everything. Yeah, we erase this two angles for a while. You can see that in this triangle which I am drawing, this triangle, this is a blue angle and this is a pitch angle, and in this triangle also this is a blue angle and this is a pitch angle. So from standard properties of triangle we can say that this angle here is equal to this angle. Okay, so we had drawn one of them by green, so let's draw again one of them by green. Basically angle bisector means equal angles, and we have shown that this whole angle is equal to the other whole angle, so we can say that this angle is also green and this angle is also green. So all four angles here are equal. Okay, so now if we want to prove that PO1 equal to PO2, what we do, first we draw O1 O2, and it's very well known that O1 O2 is perpendicular to this line, so let's keep it like this. And now what we do is, notice that if we consider this small quadrilateral here, notice that this is a cyclic quadrilateral. So if this angle, suppose we let me mark some points before that. Suppose we mark this point as say L, okay, and this point as M. So if we draw ALO1M, so ALO1M looks like something like this. Okay, this is perpendicular, and this is O1 ALM. Okay, so suppose this angle we write as X, so this is 180 minus X. So angle LAM is equal to X. So basically LAM is X, and if we know that LAM is X, as I had shown earlier, we know that this angle is also X. This angle is also X, and in an exactly same manner we can conclude that this angle is also 180 minus X, and we had proved that this angle is also 180 minus X, so these two sides are equal. Okay, that is one point, and so we basically get that this side is equal to this side, because the PO1 O2 is an isosceles triangle, so this directly follows. Okay, now we simply need to prove another point, is that is, now if we prove somehow that this angle here is equal to this angle, then we would be done, because that would imply this side is equal to this side and would be basically done. Now to do this, notice this particular quadrilateral I am drawing. Suppose we name this as say which point is not taken. Suppose we name this as E. So notice the quadrilateral which I am drawing here, this quadrilateral. Okay, If we notice this quadrilateral, we can see that this angle here is 90 and this angle here is 90. So basically this implies that this is a cyclic quadrilateral, and we can directly say that this angle here is also equal to the green angle. Why? Because AMEO2 is cyclic. AMEO2 is cyclic. So from that we can make this conclusion that angle O1 O2 Q is equal to green. O1 O2 Q equal to green angle. I'm writing only green here. So in a similar manner, in an exactly similar manner, we can conclude that this angle is also green angle. Why is that? Because see, if we now look at this quadrilateral here, this is also a cyclic quadrilateral because this is 90 degree and this is 90 degree. Why is this 90 degree? Because this is the perpendicular bisector. Okay. So this quadrilateral is cyclic, and from that we can conclude that this green angle is equal to this green angle, this angle. So this both of them are green angles. Now we are actually done with the problem because this proves that this is equal to this, and we have shown that Q is equidistant from O1 O2, P is equidistant from O1 O2, and the locus of equidistant points from two fixed points are its perpendicular bisector. So this directly implies that PQ is the perpendicular bisector. Okay. So this was the problem. Thanks.